Welcome back at Maths with Gustin. Let's have a look at question 6, November 2022, grade 11 Maths paper 1. We have got a couple of questions here. This question is consist of 10 questions. I did break them apart, yes, just for that you can have space to illustrate how would you go around answering these questions. And then let's have a look at now 6.1. 6.1, it says that write down the asymptotes of f. Okay, we see that f here is a hyperbola, and then we have got g of x is given, it's an exponent function. All right, so therefore 6.1, you would know that if you are given a function by this, I'm gonna try to write something else here. Let me just illustrate an example with this one that is given here already. F of x, if f of x was given by 2 all over x minus p plus q, we know that pq, these are the lines of asymptotes. All right, we know that pq would be asymptotes. Okay, all right, great. So having that in mind, or having that concept in mind, now let's go ahead and answer this question. F of x, this, it means our asymptote here is 2, and then also x, it's like you are solving for x is going to be equal to 2, therefore the other asymptote is y is equal to 1. Okay, and that's how you would deal with that one. Okay, 6.1 says write down the equation of asymptotes of g. All right, g, it's a exponent, only has one asymptote, which is given by minus 1 there. Therefore 6.2 is going to be y is equals to negative 1. Okay, if you ever look at the general formula of an exponent, you would know that this is q, therefore q, it's therefore an asymptote. If you don't understand, please guys, just go have a look at a video. There's a video that I did on lessons on exponent. It explains very thoroughly all the important functions, but as we go along, I'll try to explain it as much as I can here. All right, it says here 6.3 says on the same set of axes, okay, sketch the graph of f and g on your answer book. Clearly indicate all intercept. It means they are gonna asking us for y and x intercept and all the axes of asymptotes, which we just found here at 6.1 and 6.2. all right, so 6.3, okay, let's start with f of x, which is our hyperbola here. Let's look for those lines of asymptotes here. There you go. So let's look for x inter. We know we get x inter when y is equals to 0. So therefore y is equals to 0 is going to be 0 here, is going to give us 2. X minus 2 plus 1. Okay, we need to solve for x here. I'm going to take 1 to the other side. It's going to give us minus 1 is equals to 2 all over x minus 2. Therefore, do the cross multiplying. All right, if I cross multiply, I'm going to have minus 1 here. X minus 2 is going to be equals to 2. Divide everything by minus 1. Guys, this is just algebra. I know you are thinking you could do this a bit different. No problem, as long as you get to the right answer. Minus 2 is equals to minus 2. Therefore take this 2 to that side here. You are going to have x is equals to 0. So when y is equals to 0, x is equals to 0. That's our x intercept. All right, okay, now let's look at y intercept. Okay, for the same function, y intercept. All right, let me just make a line here. Y inter, we get y inter when x is equals to 0. Okay, so it's going to be x is equals to 0, 2, 0 minus 2 plus 1. If we solve this, we're gonna get to an answer is gonna be 2 divided by negative, is going to give us negative 1 plus 1 is gonna be 0. So therefore when x is equals to 0, y is equals to 0. All right, great stuff. So now let's come here. I'm gonna write up here, guys, for the sake of space. Already we are done. Let's come here and deal with a g of x. G of x is given by half to the power of x minus 1. Therefore, if you ever look at this equation here, let's start by looking for x inter, which is our x-intercept. We get them when y is equals to 0. So therefore 0 is equals to half to the power of x minus 1. Okay, if you do that, you're gonna take 1 to the other side, is going to give us positive 1. Excuse me. This is as good as writing t to the power of negative 1 to the power of x. Okay. All right, so this one, before it was 1, it was 2 to the power of 0. Therefore, when you multiply the exponent here, 2 to the negative 1, negative 1 times s is going to be 2 to the negative x. Therefore, this will there give us the exponent. The bases are the same, you are multiplying, therefore the exponent will therefore be equal. So this will just give us x is equals to 0. Okay, now let's come here, we're going to look for y-intercept for g. We get y-intercept when x is equals to 0. So we're going to come here and substitute x is equals to 0, 1 over 2 to the power of 0 minus 1. Anything to the power of 0 is equals to 1, so it's going to be 1 minus 1, which is therefore g of x is equals to 0. So all the intercepts here, they're equal to 0, so we can therefore sketch our graph. I'm going to try to have a space here. Okay, here we go. Just gonna draw our Cartesian plane here. There we go. Y, x. All right, now we need to draw the lines of asymptotes, which are given by x is equals to 2. I'm gonna assume that 2 is here, and therefore y is equal to 1. There you go, lines of asymptotes. And therefore I'm gonna draw them. Then let's draw hyperbola with red, and then we'll draw exponent with any color, with a different color. All right, so these are the lines of asymptotes for the hyperbola, which is the f of x in this case. There you go. So these are the points, these are the lines where the graph won't touch. Okay, so therefore with that, we know our x-intercept and y-intercept is 0, 0. So our graph is going to look something like that. It's going to pass here at 0, 0, then go all the way down. So this is f of x. All right, and therefore also even on this side we are gonna have that f of x. All right, okay, great stuff. So let me come here, change the color, and then we now draw the exponent. Right, let's draw the exponent function here. What is the asymptote? Is negative. Yes, it's given by negative 1. All right, let's just come here, say negative 1, y is there. There is our negative y. There is our lines of asymptotes in dotted line there. Therefore, what is the x-intercept and the y-intercept is 0, 0. So it means this graph is going to pass here. All right, what is a? A is positive. So therefore, our graph is going to look like this. There you go. It will not touch the asymptotes. There is our graph there. This is the g of x. And please guys, I mentioned something. I said a. This is a or b. Eh? So if it's positive, your graph will have a positive gradient. Okay, if it's negative, therefore your graph will have a negative gradient. All right, so and that's how you would deal with this one and how you would sketch these graphs here. Now let's move on to 6.4. all right, let's have a look at 6.4. 6.4 is saying that 6.4 it's saying I should have brought the sketch this side, but it's fine, no problem. We'll deal with it as we go. I hope you guys you have drawn the graph as well on your side. Okay, what I can do now, 6.4 says write down the domain of x. The domain of x is referring to the x values of the f of x graph, which is our hyperbola. So therefore x is the element of all real numbers. It depends on how you want to write it, guys, but x will never be equal to 2. Why? Because 2 is the line of asymptote, where so it will never touch that figure, but it's the element of all real numbers. So it can be from a negative infinity to positive infinity, but not x is equal to 2. All right, straightforward. 6.5 said write down the range of g. All right, so they are looking for the y values of g. Remember, on g, line of asymptotes was y is equal to -1. So therefore, from that line of asymptote, you would have this function of g, which is our exponent. So therefore, having that in mind, therefore our range will be from y it's greater than -1. So wherever there is anything that is greater than -1 on this function, you will see the graph of an exponent, but anything below that, the graph will never cross y is equals to -1. All right, 6.1 6.6 rather, determine the equation of h, the axis of symmetry of f, which has negative gradient. All right, okay, so for a negative gradient, you are going to have a gradient of -1. Whenever, guys, they say negative gradient, you're going to have a gradient of -1. So this is a negative gradient. Let's say, for example, the question says a positive gradient. So if the question said positive gradient, you are going to have m is equals to 1. So therefore, this would be your positive gradient, guys. All right, so in this case, we are dealing with a negative gradient. They're asking us axis of symmetry. So which points do you use to find this equation? You're going to use the points of the asymptotes. Okay, so if you can still remember points of asymptotes, we had x is equals to 2, and therefore y is equals to 1 for this hyperbola. So therefore, what you do now, you need to find this equation. Therefore, you are going to use the equation of a straight line from analytical geometry, guys. Please don't forget this, which is given by y minus y1 is equals to mx minus x1. All right, so therefore, you've got the gradient, you've got the y point, the y minus 1, the gradient of -1, x minus 2. All right, so the only thing that we need to do now is to remove the bracket. Okay, y minus 1 is equals to -x. So -1, I'm here, guys, I'm removing the bracket here. Okay, can you see that? All right, -1 times -2 is going to be +2. All right, okay, then we're going to take 1 to the other side. Y is equals to -x plus 2 plus 1. Therefore, our equation is going to be -x plus 3, and that would be the equation of the line of an axis of symmetry, guys. All right, okay, so 6.7 it's simply saying that 6.7 says describe how the graph of p of x, which is given by 2 over x, was transformed from f. Okay, how was this graph transformed from f of x, guys? If you can still remember, f of x was equals to 2x minus 2 plus 1. So now they are saying now this graph is p of x is equal to 2 over x. So what happened here? So basically what happened, this 2 is gone and the 1 is gone. So what happened? How did the graph shift? So the graph shifted. Okay, this is what we need to do now. Let's just check. In order for this graph to shift, you need to add +2 here, therefore 2 will disappear, and add -1 there, therefore 1 will disappear. So if you add a +2 there, what does that mean? It means 2 units to the right, 2 units to the right. So it means now 2 units to the right. Therefore, it means if you were to add plus, if it means here, if you were to add plus 2, therefore it means it will be 0, then you're going to be left with x. So how you're going to make this one disappear? You're going to have to move 1 unit downwards. And therefore 1 unit downwards. Can you see, guys? Simple, straightforward, guys. If you stick to the basics, I don't expect you to struggle, but guys, I know these things can be a bit tedious. So if you are struggling, please reach out to me. My number on my WhatsApp number is there on the description of the channel. You can also check me out on TikTok. I have got my number there, or you can just leave a comment, guys, and then I will assist you where I can. All right, so let's move on to 6.8. Alright, 6.8, calculate the distance between the intersection of F with G and the intersection of the asymptotes of F. Okay. This question, it's a bit, okay, the intersection, where are the graphs intersecting? Okay, let me come here, guys. I hope you guys can still remember the sketch. The sketch of the graph was something like this. I'm just going to give you a rough sketch here of how the graph was looking like. And then we had a line of asymptote there, then we had a line of asymptote there. Okay, this was our exponent, which was G, and then we also had sorry, this was our F, ne? Yeah, this was our hyperbola rather, and then it also moved here and hitting 0 0 there, and then our G, which was it was here. Okay, so this is F, this is F, and this is G. So now the question is asking us the distance between point of intersection, which is this point here. So what is the coordinates there? We know the coordinates there, it was 0 0, and therefore they also say the intersection of the asymptotes of F. Okay, where F is intersecting these asymptotes here. Where is F? F is here, is intersecting these asymptotes here. So the point of intersection at the asymptotes, we know the coordinates of asymptotes of F, which is 2 is to 1. So having that in mind, you can go ahead, guys, from analytical geometry, then you use the distance formula. But the most important thing, guys, while I'm writing the formula, because it's there on your formula sheet, can you see that the most important thing here, guys, is just the interpretation? Okay, which is something that I always say that if you're going to look at the memo and say, no, I know these things, I know how to do them, I really don't need assistant and whatnot, guys, a memo doesn't talk, a memo does not explain these things. So please make sure that you thoroughly understand the basics. If you don't understand, you can reach out to me, leave a comment, or you can ask your teacher or ask your classmates, because really, guys, the basics are very important. They should be able to assist you to answer each and every question that comes in an exam, regardless of how they ask it. Okay, all right, so now let's come here. I'm gonna choose this one as coordinates number 1, and this will be number 2. So therefore, close bracket here, open bracket, 2x is going to be 2 minus 0 squared plus y, which is y minus 1 all squared. So therefore, I'm not going to even waste time. I'm going to punch this directly into our calculator, and I found that it's going to give us square root of 5, which is equal to 2.24. Okay, and okay, let's just tell them that units here, because you know these markers maybe sometimes will say, yeah, no, it didn't write the units. Yeah, we don't need the units. Okay, moving right along. 6.10, 6.10, it says for which values of x is, very interesting question, guys, and I know guys, these are simple 2 marks. These are one of those marks where they could prevent you from getting the total, all right, from hitting that 100%. So let's make sure that we master these questions, guys. So I'm gonna try to explain them a little bit here on how to deal with a question like this one, guys. This what it means here, it means where at any given time in the graph of x and g, where would you, when you multiply the two functions or the two numbers that you get, let's say you want to check x minus 1. If you put x minus 1, x minus 1, whatever answer you get, when you multiply them together, they must give you a number that is greater than 0. So when will that occur? Okay, it will only occur if you've got a positive number times by a positive number from G. You are gonna get a positive answer there. If you have a negative number multiplied by a negative number, you should be able to get a positive answer. Guys, please, this thing also applies when you are if the question was f of x divided by g of x greater than 0. So even in this instant, guys, when in any given time in the graph you would have a positive number when you divide the two functions together, it's when you've got a positive number divided by a positive number, you should get a positive answer. Therefore, or when you've got a negative divided by a negative number, you should get a positive answer. So basically, this is what it means, guys. So if you have this in mind, you should therefore be able to answer any question whatsoever, because now you just have to go and look at your sketch. Okay, so which is basically what we're going to do here. Let's have a look at our graph now and say, okay, when will these two graphs, when you multiply them together, they'll be positive? It will occur. The other critical thing, how can I forget this, is that if you've got an x-axis there, let me just put it here. This is your y, this is your x-axis. Guys, anything, all right, anything in your sketch, anything that is below the x-axis, okay, anything that is below the x-axis. What is happening now with, okay, there you go. Anything that is below the x-axis is negative. Anything above is, so on the graphs, whichever function is below the x-axis, we consider that as a negative. Therefore, it's like this is a boundary between negative and a positive. All right, guys. So now let's have a look at our function. When will both function be negative? All right, both functions are negative here. Here's the line of asymptote there. Both of them, they are negative here. All right, and both of them are positive here. There you go. Greater or equal to 0. So it means even the 0 is included. Okay, so now, okay, I should have used a different color there just to illustrate what I'm saying here. I'm saying here, this is 2. Remember, this is 2. Therefore, here you've got 1 there as a line of asymptote. So anything that is here, both of these functions are negative. Do you agree? Yes, guys, because they are all below the x-axis. All right. Okay. But, okay, there's no but. All right. So even here as well, including the 0, because it said greater or equal to 0, both these functions are above the x-axis. So therefore, what is going to be our answer? Our answer here, 6.1.0. I hope, guys, I did explain this to the best of my ability. So any x value that is less than 2, you would have these two functions. If you multiply them together, they will give you a positive number. You can try it, guys. You can try and choose x is equals to 1, okay, and substitute it into f of x and g and see what number you'll get. You get a positive number, and they say a positive number multiplied by a positive number, you get what you get. You get anything that is greater than 0. Even here, guys, even if you come here, you are going to have, let me see, you are going to have a positive number times a positive number as well. All right. So, and that's how you would deal with a question like this one, guys. I am Gastin Mapala. Let me see you on the next upload. We'll be doing question 6, November 2021.